Welcome back to the course Energy Resources Economics and Sustainability. In the last class, we have been discussing some of the methods for investment appraisal, and we'll continue the same discussion with this in the same class. In the last class, we have been discussing some of the basics of the net present value method. The basic of the method is that we would want all the future cash flows to be discounted to the present value, and then add them up together. If they come up to be positive and the project is found to be profitable and might be applied in the future, and this same methodology could also be used for evaluating different energy efficiency options. In that case, we would want to select an option which has the least NPV. Let us also try to do a simple question with respect to NPV before we move to other kinds of investment appraisal methods. So, let us take an example of any corporation which has issued a number of 10,000 rupees 15 years bond at the rate of 6%. So, what happens in the form of bond is that the company would issue a bond, say 10,000 rupees for the individuals or the corporates to take in. The length of the bond is defined. So, the company will give the exact amount of the bond at the end of 15 years. In addition to that, it will be giving an interest that is paid annually at the rate that is defined. So, in this case, it is 6%. So, the company will borrow around 10,000 rupees from you, and it will return the exact 10,000 at the end of the 15 years. In addition to that, as an interest, it will be giving 6% interest on the borrowed sum every year for the issue of the bonds. Now, suppose there was a person who bought the bond at the onset, but now the condition is that it has been 10 years since the bond has been issued, and the person is in the need of money, and he or she would want to sell the bond for rupees 9,400. And now you would have to decide whether it's profitable for you to buy this bond or not. Your discount rate for these kinds of investment could be 6.8%, and let's try to do a simple calculation wherein we'll try to estimate if we should go for buying this bond or not. So, if we would want to calculate the NPV, the first thing we would have to make a payment of around 9,400 today for buying the bonds. Then I would be getting an interest of 6%, which would be 600 rupees on an yearly basis. So, that starts from the next year. So, it would be 600, and I divide that with 1.068, which is my discount rate for these kinds of investments. Then I would get a similar kind of interest that is returned to me the year after that, and I would be getting such kind of returns for the next 5 years. So, I have just written the total amount raised to power 5, and also at the end of 5 years I would also get the bond value returned, which is 10,000 rupees, and that again needs to be discounted by the same factor. So, let me add all these values and try to see if it comes out to be positive or negative, and let me repeat it again. So, at present I am making an investment or buying the bond from another entity which is selling me at around 9,400. For the next 5 years or so, I will be getting the interest back, which will be 600 rupees per year, and I would want to discount that with my discount factor, which is 6.8%, and at the end of 5 years I will also be getting the 10,000 rupees back, which is the bond value. So, if I do this calculation, add them up together, this would come out to be roughly around 270 rupees, which comes out to be positive, and that it also reflects that it would be safe for me to invest in this bond, because finally I would be making some kind of profit out of it, and it is advisable to buy this bond. So, these are some of the applications of the NPV method that could be applied for a variety of scenarios that could range from setting up of an energy plant to evaluating of different energy efficiency options, and even to your personal lifestyles, where you would want to see if a certain investment by you makes sense or not. So this is one of the most widely used investment appraisal methods, but apart from this there are many other methods as well, and let us go through them. Another method that is used for the energy projects is the annual worth method. So this method again is very similar to the NPV method. And the difference here lies in that in the NPV method I am discounting all the future cash flows to the present year, whereas in the annual worth method I am taking the yearly value. So what I am seeing is the total value of the project or the total cash flows are seen as a form of an annuity. What would be the payment or the profit or the loss that is happening every year, and that is a simple value. So apart from, instead of seeing the total worth in the present year or seeing the future value, which is normally the case in the NPV method, this method basically sees the annual total cost or revenue for the project in a particular year. So it's basically converting the net present value into an annuity and to see if that makes sense or not. In effect, this is very similar to the NPV method, and this has again been widely applied in a similar way. So if I go, let us try to understand this with the help of an example. Say a transmission corporation is considering updating one of the transformers every 5 years, and it wants to ensure that it's a profitable investment. So the aim here is to update the transformer every 5 years. A new transformer costs around 2.5 lakh rupees and may be sold in 6 years at around 50,000 rupees as scrap. And an increase in revenue that happens due to this higher transformer efficiency can be attributed to around 80,000 rupees per year. The discount rate for the corporation for such kind of investment is 20%, and we would want to calculate the annual worth of this project. So the formula that we would be using for converting the annual worth or based on the present value would be, if I am talking about the annuity or the annual worth, it would be the present value multiplied by the discount rate, again a function of discount raised to the period n, 1 plus r minus 1. We had derived a similar equation in the previous classes as well, but there was a slight modification based upon whether your when the cash flows are taking place. So even if you study the different formulas that are available in the literature, the equation is going to look something similar, but there might be slight modification based upon whether the cash flows are starting from the year 0 or year 1. So this is one of the normal equations that you use, but you might come with a slight variation, or you can also derive it. We have done the derivation in the previous classes, and the equation could look very similar, or it could be a slight modification based upon when do you consider the cash to be flowing in. Is it from the year 0 or from the year 1? Again, there are two kinds of annuities that are considered. One is the annuity due, and the other is the annuity payable, and depends upon when are you paying the annuity. Is it at the start of the financial year or the end of the financial year? So coming back to the example, so if I take consider the annuity or for the annual worth of 2.5 lakh rupees of investment, and I put that in the formula, the value would come around to be roughly 83,594, which would be a negative because I have an investment to make. My profit that happens is around 80,000 per year, so I add that. Further, I also make a gain because of the selling of the transformer at the end of 6 years. So even that needs to be equally divided among the 6 years, and I can use the same formula and I'll get the value of around 6719. So I would want you to do the calculations at your end. So again, let me repeat. So the first thing is I would want to divide 2.5 lakh rupees throughout the lifespan of 6 years, and this is what the value looks like. My yearly gain from this transformation updation would be 80,000 rupees, and again I make a gain by the selling of the scrap of the transformer at the end of 6 years, which is 550,000, and even that needs to be equally divided among the 6 years and discounted as per the discount rate, which is 20%. I add these three values together, and the final value that I get is around 3125 rupees per year, and it comes out to be positive, and I can go for this project. If this was to be negative, I would have not been in favor of this project. One of these advantages of the annual worth method is that I can, if the price of the different commodities or the price flows are increasing in a similar fashion, I can keep on using this method perpetually. I don't need to be dependent upon the project life of 20 years or 30 years. So in this case, like the transformer would be replaced every 5th year or so. So I can use the same methodology, and I am pretty sure that it will be making profit for me because it's based on an annual basis rather than a project basis. So that is one of the advantages of this particular method. Further, and there could be another method which is called the average return on books. So the book in this definition of an average return on book is basically the book value, which is an accounting concept, which is basically the capex of that you have put in minus the depreciation that would be happening, and it depends on the depreciation schedule that you would be following for the capital asset. And this kind of methodology is basically coming from accounts background, where you would want to see the book value, and what you would do is you would divide the revenues by the average book value of a particular project, and if that comes out to be more than what your minimum acceptable return is, you would go for this project. So again, let us consider a simple project in which you would make an investment of around 9,60,000 rupees, and then this investment you are expecting would depreciate using a straight line method. So straight line method basically entails that the investment is linearly decreasing in its value, and that happens for the first 3 years. And from this project you also have like a revenue that is generated, and that revenue generation happens to be around 2,16,000 per year. So basically this is what the table for the annual average return on books would look like. So you would have an initial investment of 9,60,000 that is occurring in the year 0, and there is no other capex for the following 3 years. And this capex would be losing its value linearly. So in the first year it will be losing 1/3 of the value, which is 3,20,000. Another 3,20,000 in the second year, so the total depreciation comes out to be 6,40,000, and finally all of it would depreciate in the year 3. If I consider the book value would be the total 9,60,000 in the year 1. I subtract the depreciation for the year 1, and this would come out to be 6,40,000 at the end of year 1. And then at the year 2 I subtract 6,40,000 from it, which brings me to 3,20,000, and finally the book value would be 0 at the end of 3 years because all the value has depreciated. If I talk about the income would be constant for the total 4 years, which would be 2,16,000 or so. So if I would have to evaluate the average return on book, so first thing is I would take in the average value for the 4 years, which is 9,60,000 plus 6,40,000 plus 3,20,000 plus 0, which is at the end of 4 years, and divide that with 4. So this is basically the average book value that I have, and for the average return on book value I would just subtract the revenue, the average revenue, which is 216,000, and the value of this particular case would be around 4,80,000. This is the previous calculation, and so I divide this by 4,80,000, and the value would come around to be around 0.45. So, if this book value is more than the minimum acceptable value based upon my experience in the past, I would go with this particular methodology. If it's less, I would discard this particular plant. Again, as you would have understand, like there are a few disadvantages of this particular methodology. One is that it doesn't take into account the time value of money. So, an income in the year 0 is equivalent to the income in the year 3. So, there is no time equivalence of the different payments that is taking place. Further, this also depends upon the experience of the accounting firm with the different kinds of investments. So the ARB method cannot be uniformly adopted by the different kinds of organizations. So again, this is one of the type of investment appraisal methods. Further, in this investment, if another investment was occurring after 3 years or 4 years, it will be difficult to account for that. So that's another disadvantage. Then another kind of investment appraisal methodology that is used by different types of industries would be the payback period. So payback period is basically the number of years that I would need to recover my initial investment. So this is basically the initial investment divided by the future cash flows, and whenever the total cash flows are equivalent or more than the initial investment that I made, that is basically said to be the payback period, and it normally varies from 2 to 8 years. Let us try to understand with the help of a simple example. Say if I am setting up a plant with an initial capex of 10 lakh rupees, that's my initial capex, and the revenue that I am generating, say I am just taking an arbitrary case, it's rupees 1 lakh rupees per year for the maybe the first 2 years, and then the revenue increases to around 2 lakh 10,000 rupees maybe thereafter. So for this kind of investment, if I am trying to look at the payback period, this would come around to be around 6 years. Because by the end of 5 years, the total revenue that I would have generated is 1 lakh for the first 2 years, that brings up to be 2 lakhs, and then 2 lakh 10,000 for the next 2 years. So it's next 3 years I would say, and this would be around 8 lakhs 30,000. So if I talk about 5 years, the total revenue that I have made would be around 8 lakh 30,000, which is less than my initial investment of 10 lakh rupees, whereas at the end of 6 years I would have made almost around 10 lakh 40,000 of revenues, which is again greater than 10 lakhs. So I would assume 6 years to be my payback period. Some institutions or like some kind of entities would want the exact payback period, and you can do that as well. So in this calculation it will come around to be 5 years 10 months if you want the exact payback period. Again, this is one of the methodologies, but again not widely used and accepted, because as we can see, the thing that is absent here is the time equivalence. We are not taking into account the discount rates. The other thing is, if the investment entails that there is a major capital expenditure that is occurring maybe down the line 5 years or 6 years, it doesn't take into account for that investment. We can also try to understand some of like the difference with the help of few hypothetical cases. So herein we have 4 different projects, and we'll try to compare the payback period and the net present value of these 4 hypothetical cases. So in these we have the cash flow that is occurring in the 4 years, starting from year 0, year 1, year 2, and then year 3. So the initial cash flow or the initial investment is the same for all the 4 cases, which is 1,60,000, and I am taking a negative figure. And then their revenues could be somewhat different. So in the first case, I am having a revenue of 80,000 for the next 2 years, and then a revenue of 4 lakh rupees. For the second case, I have a revenue of 1,60,000 in the second year, and there is no revenue in the first year. And finally, in the third year, I have a revenue of 4 lakh rupees. In the third case, the revenue jumps in the third year almost to around 80 lakhs. And finally, in the case of D, we have a revenue that is just coming at the end of second year. So we can see, if I use the simple payback method, the payback value of all the 4 different projects or investment would be the same, that is 2 years. I am able to recover my capex in the first 2 years. So in all the 4 cases, the addition of cash flow 1 and cash flow 2, CF1 and CF2, is either equal to or more than that of CF0. So the payback period is 2 years for all the cases, whereas if I look at the NPV, there could be highly different. So we can see for the project C, because of for a jump in the cash flow that is happening in the year 3, which is beyond the payback period, so it's not able to account, and the net present value is way more as compared in the previous 2 options. So this is again a major disadvantage of this methodology, which is unable to look at the cash flows that are occurring beyond the payback period. Further, it also says that a payback period to be quite small for an investment that is expected not to be profitable at all. So if we look at this investment, it's not having a positive net present value and not expected to be profit making strategy for the future. But still, because this particular methodology is not taking into account the time value or the time equivalence of money, it has that disadvantage. And to overcome this disadvantage, people have proposed that the cash flows might be discounted by a discount rate of the entity, while this brings up a better methodology in terms of payback period. But still, the inherent inability of the methodology to account for any cash flows that occur beyond the payback stays there, and that does not go away. So if there is a major revenue jump that is happening beyond the payback period, or a major investment that occurs, or a major replacement cost that might occur beyond the payback period for a particular project, it might not be taken into account and might not give you the right decision making power with the help of this tool. So these are some of the advantage and disadvantage with respect to the payback method. Beyond this, we also have a methodology which is called the internal rate of return. So again, internal rate of return is something that is equivalent to the net present value. Internal rate of return basically gives you the discount rate at which the net present value of a particular project, accounting for all the cash flows through its lifestyle or lifespan, would be 0. So let me repeat it again. Like, internal rate of return is basically giving you the discount rate at which the net present value of a particular project, taking into account all the future cash flows including capex, opex and revenues, would add up to be 0. So as you would have understood, and this is basically solving a non-linear equation, so it has a computational cost to it. But further, if the internal rate of return that you get as an answer is more than the minimum acceptable rate of return for your entity or for your corporation, you would go for this project, and if it's lesser than that value, you would basically discard this process. How do you solve it? So normally the solution is achieved by different iterations. There are different kinds of methodologies, and most of them rely on the trial and error methodology. Let us try to understand this with the help of again an example. Let's consider 3 different projects that would be there, and we have the total cash flows of these projects as well. So we can have the cash flow 0, which is basically an investment, and then the cash flow for the next 5 years or so, and the cash flows are shown in front of you. And what you see in the last 2 columns is basically the IRR in terms of the percentage, as well as the NPV for this for the projects. So what we see for the first 2 cases is that the IRR for the first project, that is project A, comes to be way more than the project B. So, the project B has an IRR of 20%, whereas the project 1 has an IRR of 33.4%. So, if I go with an IRR methodology, I am expected to go by project A, whereas if I look at the NPV, this is the opposite. The project B has a higher NPV than a project A. So, if these two methodologies are basically following a similar kind of analysis, why are the results different? The difference lies in the NPV, the IRR basically gives us the how fast money is coming back to us. So, in the case of project A, what you see is that the investment is given back to you at a pretty fast rate. So, all the investment is coming back in the first 3 years. And if you add them up together, like you are not gaining much, whereas in the case of B, although the investment is coming back to you slowly, the total amount of money that comes back in the next 5 years is somewhat larger. So, an IRR methodology is used by corporates where they would want to see how fast the money is recovered, because an investment in a risky business also entails that you would want to recover the money as fast as possible. You might want to lose some money rather than losing all the money. So, you would want to recover as fast as possible. Again, the two methodologies are expected to give you a similar result if I would have adopted a higher discount rate for the NPV methodology. So, in this case, the discount rate that was chosen for this calculation was around 10%. If the discount rate was beyond 15.8% or 16% or more, both the methodologies would have given you a similar answer. Further, we can see two methodologies or two projects which have the same IRR. In the case of project B and C, both happen to have an IRR which is almost similar in terms of 20.2%, would have a very different NPV as well. So, in this case, it becomes difficult to which particular methodology you would want to go for. So, again, IRR is a good methodology that has again all the three features of a good investment appraisal methodology. It takes into account the entire span, considers the cash flow over the entire span of the investment, and also takes the time equivalence into account. But when it comes to solving these equations, it could be computationally intensive, and further it might not always give you the best answer. For best answer, you would want to use the IRR methodology in conjugation with NPV or some other methodology. So, like in this case, the two investments are coming to be similar in terms of IRR, but it would need you to do a net present value analysis as well to understand which project would generate more profit over the lifespan. So, as we have discussed, as a rule of thumb, NPV is one of the simplest methodologies and one of the most widely adopted appraisal methodology that you would find very often in all the popular literature, as well as different reports which would want to compare the different kinds of methodologies. And beyond that, we also have a methodology that is the external rate of return. So, what happens in the external rate of return is that we would want to compare the different kinds of investment on a similar lines as the IRR, but in this case all the investment or all the cash flows that are negative or that are outflows would be discounted to the year 0, whereas all the inflows or the profit that you would be making are discounted to the final year. And it uses a rate of return which is called the external reinvestment rate, IER, that is again defined by the management of a particular company. And then it would involve coming at another interest rate which is called the IERR, which would be used to equate the present value of all the outflows equal to the future value of all the inflows. So, you would want to generate or come up with the interest rate that would equate all the future outflows taken in the present values and all the inflows taken at the future value, and see if the interest rate that you come up for equating these two values is more than the minimum acceptable rate of return. Further, this kind of methodology would entail that you are wanting to determine three different interest rates, which is the external reinvestment rate, the interest rate ERR, and the minimum acceptable rate of interest. And this also brings in the element of uncertainty, because these are a few values which are specific to a management of a corporation, and that is one of the reasons, again, not many people would want to use a methodology like this. Finally, we would come to another methodology which is called the profitability index. So, in the profitability index, it's also called as the benefit to cost ratio. It's basically dividing all the revenues that are being generated through the lifespan of a project and divide that with the initial investment. So, I am taking the discounted cash flows that are happening in the future and I divide that with the initial investment. So, for defining a profitability index, so if you have different cash flows occurring at different time spans, so I would define the profitability index as the cash flows, and that starts from year 1 when you are having revenue generation, and that would normally be divided by a discount rate. A cash flow maybe for the second year, for the discounting it, and goes in till the year n, which is again discounted. So, and I divide that with the initial investment that I am making in the year 0. So, if I have to define this, this is profitability, it is 1 by I, and the summation of n going from 1 till the year n, and this would be CFI divided by 1 plus R raised to power I. So, this is a normal notation for this. Again, this methodology takes into account the cash flows throughout the lifespan of the project, and further it also considers the time equivalence. But if in case the investment is spread to more than 1 year, maybe 2 to 5 years, which is the normal case for energy related project, this is a shortcoming of this project. And further, if there are investment beyond or in the middle of the project, which again is something usual for energy related project, these kind of this methodology might not be able to accommodate that quite well. So, with this we have tried to understand the different kinds of investment appraisal methodologies that could be applied for evaluating different kinds of energy related projects. We have tried to understand the basics of net present value, the annual worth method, the payback period, the internal rate of return, the profitability index, the average return on books. So, these are some of the methodologies that you might come across when you are studying different kinds of investments in the energy related domain, and now you understand how these calculations are being done. The most common and the easiest and the most widely acceptable method is NPV, which you will find in most of the cases. And in the future, we will also try to understand these concepts with the help of more concrete examples. Thank you.